Today we're going to continue our work in Chapter 9, Chemical Reactions. Reminding you, we are working on learning goal number 2, the students will be able to predict products of a chemical reaction. Now would be a good time to pause the video and take out your periodic table and goal sheet in order to help us do some example problems. So far we've talked about 3 types of reactions. Synthesis reactions. We identify a synthesis reaction because there's only one substance on the right side of the reaction, one substance after the yield symbol. We've covered combustion reactions. The way you identify a combustion reaction is oxygen, O2, will be one of the reactants. We've covered reaction type 3, decomposition reactions. In a decomposition reaction, you have to add some type of energy over the arrow, and there will only be one substance in the reactants. One substance breaks down into 2 or more simpler substances. Today we're going to focus on reaction type number 4, single replacement reactions. Again, make sure that you have your gold sheet and periodic table out to help you. Okay, single replacement reaction's pretty simple. It says here it's a reaction in which the atoms of one element replace the atoms of another element in a compound. Let's take a look at the example equation. We've got element A, a lone element all by itself, and it's being added to compound BX. In this case, A comes in and kicks BX out of the compound. And we end up with AX, compound AX, and now a lone element B. We recognize this as a single replacement reaction because a single lone element has kicked another element out of a compound. And we've got lone elements on both sides of the reaction. Let's take a look at the second example. We've got the lone element copper. Everybody see copper here? We've got silver nitrate, the compound. Copper is being added to silver nitrate. And what happens is the copper will come kick the silver nitrate out. And we will end up with the lone element silver. Silver got kicked out of the compound over here. And we will end up with a new compound, copper 2 nitrate. Pretty simple. Again, we recognize that these are single replacement reactions because there is a lone element on each side of the reaction. Lone element kicking out another element in a compound, and we end up with a lone element and another compound. Okay, in order to figure out if a single replacement reaction will occur, we need to check the activity series on the back side of our gold sheet to see if a single replacement reaction will occur. It says here a metal will not always replace a metal in a compound dissolved in water because of differing reactivities. An element may not replace another element in a compound unless it is higher or more reactive on the activity series. Let's take a look at our last example. In this example, let me go back here. In this example, we had copper, a lone element, trying to replace silver. Metals can only replace metals. The only way that copper can kick silver out of this compound is if copper is a more reactive metal. Copper needs to be higher than silver on the activity series. Let's take a look at the activity series. So the 2 elements we were looking at were copper, the lone element, here it is, and then silver, right below it, the element in the compound. Is copper more reactive than silver? The higher elements, okay, are more reactive. Higher elements, most reactive. Copper, the lone element, was higher than silver. Copper, the lone element, is higher than silver, so the reaction will occur. Let's take a quick look here. Copper, higher than silver, will replace silver in the compound. Pretty simple. Okay, again it says you must check the activity series on your gold sheet to see if a single replacement reaction will occur. Compounds in single replacement reactions must be aqueous or dissolved in water. Let's take a look at this first example. It says potassium plus zinc chloride. So potassium is our lone element. Potassium is a metal. Metals can only replace metals. So potassium needs to be higher than zinc on the activity series for the reaction to occur. Let's take a look. We need to find potassium. Here's potassium on the activity series. Very reactive. Okay? And potassium is trying to replace zinc. Zinc is down here. So this reaction will happen because potassium is more reactive than zinc. So this is going to yields potassium chloride, new compound, plus the lone element who was kicked out, zinc. Now we just have to write this out and balance it. So we've got potassium, it's a metal, solid, plus zinc chloride. Please balance your charges. 2 plus, Cl, 1 minus, so Cl2. Get rid of our charges. Gotta be an aqueous solution in double replacement reactions. And that's gonna yield potassium chloride, KCl, 1 plus 1 minus charge, still dissolved in water, plus zinc metal all by itself. Metals are solids. The last thing we need to do is balance the equation. We need 2 potassiums. No, that's not right. We need 2 chlorines and 2 potassiums. And I believe we're balanced. Let's check the next. Oh, and again, we realize that this is a single replacement reaction because we have lone elements on both sides of the equation. Okay? Let's take a look at reaction B, example B. It says chlorine gas plus hydrofluoric acid. I don't know if you remember, hydrofluoric acid would be HF. I'm going to write that real small here. So chlorine would need to replace another nonmetal. Nonmetals can only replace nonmetals. So chlorine in this case would be trying to replace fluorine. Let's check and see if chlorine is higher than fluorine. So down here, we have our halogens. Chlorine is right here. Fluorine is actually higher. Okay? Chlorine is the lone element. It's lower than fluorine. So in this case, since chlorine is lower than fluorine, lower than fluorine, the reaction is not going to happen. So we are going to write yields no reaction. We still have to write this out. There won't be any balancing involved. So we've got our chlorine gas plus hydrofluoric acid. Acids are always aqueous, and it's going to yield no reaction. I hope that makes sense. Let's move on to our next example. Again, we have to check the activity series on the gold sheet to see if the reactions occur. So here we have iron plus sodium sulfate. Iron is a metal trying to replace sodium in sodium sulfate. Let's check to see if iron is higher than sodium. Clean this up a little bit. Okay, we've got iron right here. Iron was the lone element. Sodium is way up here. Iron needs to be higher than sodium to replace it. So this reaction should not occur. But we still need to account for that. So iron plus sodium sulfate will yield no reaction. But we still have to write this out. Iron is a solid. plus sodium sulfate. Let's balance the charges. Sodium 1 plus, sulfate 2 minus, so we need Na2SO4. Again, that has to be aqueous, dissolved in water in these types of reactions, and we're going to end up with no reaction. Don't need to do any balancing here. Let's go to the fourth example, example D. We've got aluminum plus lead 2 nitrate. Aluminum, a metal, would replace lead, the other metal. Let's see if aluminum is higher than lead on the activity series on the back of our gold sheet. So we're looking for aluminum and lead. Aluminum needs to be higher. Here's aluminum, the lone element. Here's lead down below it. Since aluminum, the lone element, is higher than lead, the reaction should occur. We just need to write it out. So aluminum plus lead 2 nitrate will yield aluminum nitrate plus the lone element lead. Let's go ahead and write this out. Aluminum, metal solid, plus lead 2 nitrate. Lead has a 2 plus charge. Nitrate has a 1 minus charge, so we need 2 of them, parentheses and a 2. That's going to yield aluminum nitrate. Aluminum has a 3 plus charge. Nitrate has a 1 minus charge, AlNO3-3. Remember that our compounds need to be aqueous. Plus lead, which is a metal, it's going to be a solid. Let's go ahead and balance. 1 aluminum, 1 aluminum, 1 lead, 1 lead, 2 nitrates, 3 nitrates. Ooh. So we would need 2 here, a 3 here, a 3 here, and a 2 here. Go back and balance it yourself if you had trouble understanding that. Let's move to the last, and again, if we look at both of these reactions on the page, they are both single replacement reactions because there is a lone element trying to replace another element in a compound. Let's go to the last example. We have magnesium plus aluminum chloride. Again, we need to see if the lone element, magnesium, is higher than aluminum on the activity series. Let's check it out. Magnesium, the lone element, needs to be higher than aluminum. Oh, we're going to luck out here. Magnesium, the lone element, is 1 higher than aluminum. The reaction will occur. So magnesium plus aluminum chloride, magnesium has to kick out the other metal, aluminum. So we're going to yield magnesium chloride plus aluminum, the lone element. Let's go ahead and write this out. Magnesium, it's got to be a solid, plus aluminum chloride. Let's balance our charges. 3 plus, Cl 1 minus, so AlCl3. Remember, compounds in these reactions need to be aqueous. And that's going to yield magnesium chloride, magnesium 2 plus, chlorine 1 minus, MgCl2. Remember, compounds need to be aqueous, plus our lone element, aluminum. The last thing we need to do is balance. Our chlorines are off. Looks like they'll balance out at 6. So we need 2. Over here we need 3, which would give us a 3 and a 2. Again, we know that this is a single replacement reaction because there is a lone element trying to replace another element in a compound.